Hello all. The purpose of this discussion is to solve a problem that involves an ideal op-amp. And over here you can see there is an op-amp circuit with a 12k ohm resistor in the feedback path, and there are a bunch of resistors in the feed forward path as well. So in order to solve the problem meaningfully, we should do some circuit reduction, which means we should simplify a part of this circuit and here with this circuit is simplified into a very simple voltage source in series with a resistor, then the whole problem can be greatly simplified. So this is what we are going to show, and we notice that V sub t is nothing other than the Thevenin voltage of the circuit at the point of interest is A and B, and R sub t is the Thevenin resistance between the points A and B. And what we do now is, if we want to calculate the V sub t, it's very simple, because what we see here is essentially a potential divider, and this is my V sub t over here, and this is my 1 volt, and this is my 2k, and this is my 8k. So if you want to calculate this V sub t here, it's going to be the input voltage is 1 volt divided by the total resistance is 2k plus 8k, which is 10k. That gives you the current that flows through the circuit, and then we multiply this by 8k in order to calculate this V sub t. So upon simplification, we notice this is nothing but 0.8 times 1 volts, or this is 0.8 volts. And similarly, if I want to find the R sub t, all that I have to do here is I need to find the resistance seen through the terminals A and B after deactivating the voltage source. So that can be done very simply, because deactivation implies I make the voltage source as a short circuit. That means there is no voltage at all, and then here you have the 2k and 8k here, and this is the point of interest A and B, and therefore the R sub t is the resistance between A and B is a 2k parallel 8k, and we can simplify this as 16 divided by 10k, which is 1.6k. So having done that, we could replace the circuit here like this. This is the Thevenin resistance, which we calculated as 1.6, okay, and therefore we can simply simplify this by adding 4.4 to 1.6. So this RS is going to be RT plus 4.4k, but RT is 1.6 plus 4.4, which is equal to 6k. So this is essentially a 6k. So if we want to calculate V sub 0, it's very simple now, because what we see here is an ideal inverting amplifier configuration. So for the inverting amplifier configuration, we know this output voltage V sub 0 equals the ratio of the two resistors. Feedback resistor is 12k, feed forward path is 6k with a negative sign here, multiplied by V sub t. So this means this is going to be minus 2 times V sub t. Since V sub t is 0.8. This is going to be minus 2 times 0.8, which is negative 1.6 volts. And this concludes our discussion for solving this problem.